topic today is going to be how to, I would say, not properly design the games in stereoscopic 3D, but more how to increase the user experience above what we used to see in today's S3D games. So get right to the point. Get the next slide. So what will be the goals of 3D in gaming? First and most obvious one, increase player immersion in the game. So we want to increase user experience when playing the game, and that's obviously #1 goal. Number 2, make game actions or features easier for user. As an example, if you're playing a baseball game and you're playing baseball game in stereoscopic 3D, it will be a little bit easier for user to figure out where the position of the ball exactly is, comparing to the speed traveling towards you. So there's some of these actions for user going to be way easier if it has a way better perception of the depth. And finally, something we're hoping to see a lot in the next couple of years, stereoscopic 3D should allow us to come up with the new types of games that we didn't see before. I think last big genre that I would consider the new one maybe came out a year, two years ago. Even though there is a lot of innovation in the video gaming industry, there's always kind of, you can put these games in some specific genre or find something that's similar that the games is they're getting released are based on. So hopefully with stereoscopic 3D we will have something totally new. So this is kind of my opinion of current stereoscopic 3D market as far as video games go. First of all, stereoscopic 3D in games is still an afterthought. No one, as far as I know, is designing games specifically for 3D, at least when we're talking about big commercial games. And it's kind of understandable. First of all, it does increase the cost of development to create the game. Even when you have the, I would say, a typical game today, according to Sony, if you want to add stereoscopic 3D to any existing game, it will increase the production budget by, on average, 2%. That's probably true for the games that are out there, but it doesn't mean the result is what you should have as stereoscopic 3D. So I believe this cost is going to be way higher. So if we exclude augmented reality games, they're available today on both PS3 and Nintendo 3DS. They're right now only viable platforms except for PC that support stereoscopic 3D gaming. There's really no games out there. I think Andrew mentioned in the previous speech there's, I think, 40-something games out there. Each one of these games could be easily done without stereoscopic 3D, and the game will still work without losing any major gameplay element. And finally, I don't expect there will be short-term changes in this area, increasing the. There will be more and more stereoscopic 3D games, but there won't be exclusive with stereoscopic 3D. A good example is Nintendo 3DS, for example, have slider when you can not only regulate but turn off 3D effect. So if your game really required 3D, what's the point of having something like this? Even Nintendo in their developer guidelines suggests for every game that should be actually playable without 3D effect. It kind of makes it, well, strange, if nothing else. The low adoption of stereoscopic 3D, that's just kind of relative. That's my view with it. I see the adoption rate still being fairly low. Hopefully that's going to change, and hopefully that's going to change with getting better technology. One panel discussion yesterday was very interesting on this subject. Obviously, still glasses are one of the major problems why stereoscopic 3D is not widely accepted, at least in homes. And last factor are technical issues. There are a lot of technical issues in stereoscopic 3D games. So I will dive a little bit deeper in this, not too much, but just to give you some idea of what technical difficulties game developers have when they're trying to develop the game. So main one is you have less CPU and GPU time, because each scene takes on average twice as much time to render. twice as much graphic processor power, about maybe 20% more CPU power. So basically you have to render scene twice for both left and right eye. Some of the things you can use some tricks how to reduce the amount of work done. For example, the objects that are very far away in a scene, you don't really have to render them twice because distance between them will be so small, so it's not going to be noticeable. So there's a couple of things you can save. Unfortunately, there's a whole new set of problems today that start popping up in modern games today, and here are some of them. So a lot of tricks I would say that we're using today in game development just not going to work in stereoscopic 3D anymore. First one is billboards. What are billboards? It's not just billboards, it's all the objects they're in a scene in a game, they're far away from you and you will never have chance to go behind them or see them from the side. They can be easily cheated and just made out of one plane rather than designing whole 3D object. So it's very common to do it, especially with the distant objects like mountains, trees that are in the distance. Everything basically that's in the distance, it will always have the reduced number of polygons, knowing the player is not going to be able to basically see the distinction between the fully rendered 3D object and some billboard. When we have this, when we add stereoscopic 3D effect to the game, this becomes more and more obvious, and obviously we can't afford to have this kind of object because we kind of damage the overall experience. Next thing, so that automatically increases on the top of the fact that you have to render scene twice, automatically increases amount of time you have to spend. Artists have to get more, much more work to actually create all these objects with more polys, and of course it need more CPU power in the first place to render more polys. Second things are special effects that we used to see on games today, like explosion, smoke, even fog effect, that it's very cheap to do. Cheap, I mean in a sense of processor power, because graphic cards will have this effect on it. All these things either not going to work in a stereoscopic 3D or they have to be totally redone. So special effects, they cannot be, you can have smoke that's just one plane facing towards the player and you will never see that the smoke doesn't have volume. Now smoke really has to have volume, so you have to create either particles or volumetric effect in order to get this. Again, big issue and very hard to do. Next thing is depth of field. Really cool effect. They started using this extensively in games in the last maybe 2 to 3 years. Like almost every game today that has any kind of animation sequence that's done in that's not pre-rendered but it's done in in-game rendering, that will have depth of field effect. For those of you who don't know, that's when you see the object in the background, they will be a little bit blurry. Objects in the front could be blurry as well, but just something that you want the camera to focus on, where the action is, it's going to be sharp. So it gives you kind of points player where he has to put his attention when the scene's happening. This unfortunately doesn't work well in a stereoscopic 3D. It's actually kind of killed the 3D effect. One of the reasons is when you see stereoscopic 3D, so you know where the depth of all the objects is, and it's up to you as a player to decide where you want to focus your attention. So if everything has about the same sharpness, I would say it's up to the user to decide where to focus your attention. If you already have some objects blurred out, it just feels weird. It doesn't. It's not a good 3D. Last thing I put on the list. This list could be fairly huge. I just listed some of the more obvious issues we have. So the last object on the list is crosshair cursor. That's seen in almost every shooting game today. So that's not going to work as well, because where are you really going to put it? Are you going to put it on the top of the screen? Or one of the things that's done is some of the games, they have kind of simulation of laser sight on your weapon. You can actually snap this crosshair cursor on the object that you're currently looking at. But in stereoscopic 3D, it doesn't. This actually think will work, but other than that, even that will feel weird, because as you move position of your cursor, it's gonna snap to the different objects, it can look pretty weird. So this is just some of the technical issues that we have today. So how are we going to resolve all this? Basically, by smart design of the video games, take totally different approach. So the way I see this, in order to approach design of the video games for stereoscopic 3D, you can have 3 different levels or design methods, whatever you want to call them. So first one will be example of the game we have in production. It's for mobile platforms, and that's the most simplest one. Basically, only goal of stereoscopic 3D here is increasing visual experience for the user. And that, I would say, that's probably 80 to 90% of the games today on the market. That's going to be as far as they go as far in terms of 3D. So I don't know if can we see this first video now? That's going to be rendered in 3D. So the game is a typical 2D shooter. There's whole background story and everything that I think it's now less relevant. But you will really recognize right away the type of the gameplay that's very common for a lot of games. But what we did is, in order to increase the user experience, we actually put the different elements of the game on the different planes. Keep in mind, this is mobile games. Everything is very pixelated when you're showing it on a big screen. So elements are fairly flat, as you would expect in this type of game. So it's very easy to make it work in 2D if someone doesn't want to use it in 3D mode. So that's it. That will be the simplest example of how we can enhance visual experience and increase immersion of the player. Second example is our game that's currently in pre-production. It's called Tampis, and it's in pre-production for PS3, stereoscopic 3D. And that will be example where the actual stereoscopic 3D will increase, improve quality of action in a game. It's a rhythm-based game. When you have to imagine it as, like, I would say, fancy version of Guitar Hero. Whole idea is by beating the drums, player creates the soundtrack, but it actually does create based on funny monsters that are jumping around that you have to match. Hitting the drum in a moment when they hit the drum. So if you can see them in stereoscopic 3D, you can see the depth, you will have way better perception how long it's going to take them to get back to the drum, when they're going to hit, and how you're going to match the action. So I think it's going to be very clear when we see the video. So if we can start this. as you can see, just having this depth helps a lot, knowing when exactly your monster is gonna hit the drum. The game will work with a moving camera that's going around constantly, so it's going to be even more important to have this in a game. This is things that we render just to show you approximately how the game works. Okay, so that's the example that more and more games have in it. Actually, there will have some feature that will help the game. Another example I'll put here. There's a lot of first-person shooting games out there. They will have that you can say, okay, depth of knowing how far my target is when I'm shooting the weapon or gun or something doesn't really help you that much, because in a moment when you align the cursor with something and you know the speed of the bullet is really fast, so it doesn't really help you knowing how far something is. If you're gonna if your bullet's going to reach the target in 1 millisecond or 1.5 milliseconds, it doesn't really matter. But when you have a game when you, for example, shoot Catapult or Angry Bird or something, when you have this arch and path or something, then you can really see, especially following the shadow of the projectile or something, it does help a lot, increase this user experience, and it actually makes sense to make this kind of games in 3D. And finally, our last example, Burn the Rope 3D, that's in production for Nintendo 3DS. This is an example, as far as I can see it, how the game hopefully is going to look, well, not maybe look, but work one day in the future. Hopefully also not that far away from today, when developers will actually focus on a 3D game. This is an example of the game, so far only one I know, that's not really, it's not going to work without 3D at all, unless you totally redesign the game. But making this game playing on a flat 2D screen, it's going to be very, very tough, if not impossible. So I'm not sure if video is going to be very easy to understand what the gameplay is. I will try to explain it in advance. So the goal of the game, you have some structure in the space made out of rope. So you start the fires at one side of the rope, and you have to keep this fire going. In order to keep the fire going, fire always burns upwards. So you have to turn and twist and turn the rope in order to make sure that there's always enough rope to fire to continue burning, otherwise it will turn off. So it might sound a little bit weird the way I explain it, so hopefully you will understand it from the video. So like next video. So on the bottom 3DS screen, player will now use a pen or a finger to twist this rope in order to keep the fire going. If you stop, fire would just reach the top and then it will die. We'll have different shape later on that will maybe make it more obvious. So I'm going to turn this because the goal is to burn all the rope. It's burning up now. Now, I don't know if you noticed, but some of the fires actually did die just because they didn't have, like everyone that will go direction down, left or right will die, and all the other ones will survive. So that's it. That will be, I think, the best example of the game that can really only work in stereoscopic 3D, and I'm hoping to see more of these things in the future. So, ready for questions? There's a microphone in back.
Enough noise out there. It's right here, please. You need to come to it.
So some of the things you identified as difficulties, like explosions and fires, in the example you just gave, you have burning fire that seems to be done with a 2D sprite, and it worked fine.
It is in this example because this is rendered in 3D Max. It's not actually game footage, and also fire is very small. So it looks decent because there's a lot of fire, and you're action that's happening in this moment is focused all over the place. It's not just one small fire. If it's one, and if you're focusing on this, you will notice more and more these artifacts. But yeah, you're right. It could work. Just the effect's not going to be the same.
Okay. Another unrelated question. In terms of input, do you find the choice of stereoscopic 3D influences your input paradigm?
No, not that much, because obviously I mentioned at one point augmented reality games, they're working well with 3D because you're controlling everything with the cameras. But 3D, if you don't have stereoscopic 3D, the games will still be done in 3D, so you do have this perception of depth and everything. It's not as good as with stereoscopic 3D, obviously, but people are used to move their characters with a mouse, joypad, whatever, in the 3 dimension.
Okay, thanks.
Welcome.
Hi. You mentioned 3DS. I'm wondering what other platforms you're targeting for mobile stereo 3D game development?
Right now we're targeting mainly non-existing platforms. So we're making more generic games that we hope to be able to render on any platform. So we're doing 3DS, PS3, and all the cell phones with the 3D screens that are coming out. I think quite a few of them will actually come out this year.
Okay, thanks.